So, what if I told you we could solve the world's water crisis with a recipe? No, not for food, but a super precise formula that was discovered by an AI. Well, that's exactly what we're digging into today. How artificial intelligence is literally hacking our oceans to create an endless supply of fresh, clean drinking water. But first, to really get why this is such a huge deal, we need to understand the sheer scale of the problem we're up against. We live on this big blue planet, but for billions of people, all that blue is just an illusion. It's completely out of reach. Think about this for a second. By the year 2050, it's projected that at least 1 in every 4 people on Earth, that's a full quarter of the entire global population, is going to face chronic, recurring water shortages. That is an absolutely staggering number, and it's a crisis that's hitting every single continent. And here's the great, frustrating irony of it all. We are surrounded by water, literally trillions of tons of it, right there in our oceans, but we can't drink it. We have this almost limitless resource that we can't use, while that tiny fraction of fresh water we all depend on, well, it's getting scarcer every single day. So that's the big question, isn't it? It's what has been driving scientists and engineers for decades. How do we crack the code? How do we turn all that salt water into fresh water efficiently and affordably on a massive scale? Well, it turns out the answer lies in some pretty remarkable technology. For years, our best answer has been a process called reverse osmosis. It's kind of the workhorse of the desalination industry, but let's be honest, in a lot of ways, it's a bit of a brute force solution. The idea behind reverse osmosis is actually brilliantly simple. You take salt water, you apply a whole lot of pressure, and you force it against this special membrane. Seriously, think of it like the world's finest, most high-tech screen. The water molecules, they're small enough to get squeezed right through, but all those bigger salt ions, they get left behind. So you've got salty water on one side and pure fresh water on the other. And when you scale this up to an industrial plant, the whole process follows 4 basic steps. First, you've got pretreatment, which is basically filtering out all the big stuff like sand and debris. Then, these super powerful pumps create intense pressure. That water gets forced through the membrane modules. That's the heart of the system, where the real magic happens. And finally, you have post-treatment, which just makes sure the water is totally safe and ready to drink. But here's the problem. Of course, there's always a catch, right? Those high-pressure pumps use a massive amount of energy, and that makes desalination really expensive. And on top of that, those membranes are incredibly sensitive. Their performance can change like crazy based on just tiny little shifts in the operating conditions. So if you get it wrong, you're just wasting a ton of energy and money. So really, it all boils down to one thing: efficiency. To make desalination a real global solution, we have to find the golden recipe. The absolute perfect operating conditions to get the most fresh water for the least amount of energy. And that is exactly what this research set out to do. So what are the tuning knobs on this whole system? Well, the researchers focused on 4 key ingredients: the water's pH level, its temperature, the pressure in the system, and how salty the water is. The perfect combination was out there somewhere, but trying to find it by hand would be like trying to guess the combination to a safe. Nearly impossible. And this is where things get really, really cool. Instead of just fumbling around in the dark for the answer, the researchers decided to teach a machine to find it for them. They turned to the power of artificial intelligence. Now, to teach their AI, they first needed data, and they tried 2 different ways of getting it. The first way, the standard way, was pretty simple. Just change one thing at a time. But the second method was much, much smarter. Instead of just testing things one by one, it tested them in all these clever combinations, designed specifically to see how they affect each other. And let me tell you, that turned out to be the secret sauce. All of this data got fed into something called an artificial neural network, or ANN. And you can just think of an ANN as a digital brain. It's a super complex algorithm that learns by example, and its job is to sift through all that data to find hidden patterns and relationships that you or I would probably never see. Its whole mission was to learn how to predict the outcome of any combination of those 4 ingredients. And the results? They were just stunning. The AI that was trained on that simple one-at-a-time data, it was okay. It scored a 0.77. But the AI that was trained with this smarter, combination-focused data, wow, it was nearly perfect, hitting an accuracy score of 0.97. This meant the AI didn't just understand the system, it had completely mastered it. So, with this incredibly smart and accurate digital model of the whole desalination process, the researchers could finally ask the ultimate question: What is the perfect recipe? What is the formula for maximum efficiency? And the AI delivered. It found the single most efficient set of conditions: a pH of 9, a water temperature of 45 degrees Celsius, a pressure of 40 bar, and a specific salt concentration of 10 grams per liter. And these weren't just random numbers. They represented the perfect balance point for the entire system, that golden recipe they had been searching for all along. Now, this is not just some academic exercise. This recipe provides a clear, data-driven blueprint for designing and operating desalination plants everywhere on the planet. By tuning their systems to these exact parameters, facilities can produce more fresh water using less energy. And that's going to drive down costs and make this vital technology accessible to way more communities. And the impact here, it's truly global. This kind of work directly supports the United Nations Sustainable Development Goal number 6, which is all about ensuring clean water and sanitation for every single person on this planet. It's just a powerful example of how we can use advanced technology to solve our most fundamental human challenges. You know, there's a quote from the poet Rumi that I think is just the perfect way to wrap this up. If you start walking the way appears. The path to solving a problem as huge as water scarcity can seem impossible. But what this research shows us is that by taking those first steps, by applying new tools and new ways, the path forward, it really does begin to reveal itself.